Hello, and um, this is Mr. Bradley. I'm going to be talking to you a little bit about carbohydrates. So, what I'm going to be doing is writing up on my smartboard, so you'll see me in the background over here, but mostly just pay attention to what's going on the screen. So, first off, we're talking about what we would do with sugars. So, what I'm going to show here. Give me a second. There we go. So we're talking about what's going on with sugar. So let's talk about, this is someone's leg, and you have muscle inside the leg. So let's say that this is the hamstring muscle, and you're going to have blood vessels that are going to come down and feed blood to these muscles. Now, what's coming through these muscles? Well, if I were to zoom in into what's going on right here, we would see a blood vessel, okay, and then there would be like a red blood cell in the blood vessel. And then right next to the blood vessel would be a muscle cell. And the muscle cell, just like any cell, is going to have a nucleus. Okay, so there's the nucleus. And then it's going to have muscle fibers in it that actually grab and pull back and forth. And then it's going to have, kind of tucked away inside this, is going to have molecules of glycogen that are just kind of sitting in there as a storehouse for energy. And what these glycogen are going to be long chains of glucose. So if I zoom in on that glycogen, they're going to be long chains of glucose, hundreds of glucoses long and branched. The glucose will have gotten there through the bloodstream. So every time you drink a soda, eat an apple, or whatever, anything that contains glucose in it is going to be digested, absorbed into your bloodstream in your intestines, and then transported through your body, through the bloodstream, to all the different cells in your body, including your muscle cells. Your muscle cells, if they don't immediately need that glucose, so here's what glucose ultimately gets used for. So glucose, again, looks like this, and it's going to get combined with oxygen, and it's going to produce CO2 and water. But more importantly, the main thing that's going to produce is a chemical called ATP, which is going to be energy for the cell, including the energy that you need to use your muscles. So to move the muscle. Okay, because again, this cell, the way it works is it kind of like gets shorter this way and contracts, and that's ultimately how this leg is going to move. So when this muscle contracts, this leg is able to move back and forth in that direction. So we have our fuel source, but again, we don't necessarily need to use the full fuel source all the time. So what happens is when we actually need that fuel source, when we're actually doing our exercise, what happens is water comes in, and water will get broken up into H and OH. The H will go over here, the OH will go over here, and it will break off one of these OHs at the end, or sorry, it'll break off the glucose on the end so that it can then be used for energy to do the process. So and that would continue going on and on and on every time your muscle needs energy. So again, glycogen is going to be stored. So how does that glycogen actually get stored? Well, again, as the glucose gets absorbed, some of the glucose is going to be combine with other glucose molecules. So you'll have glucose with an H and an OH, and then you'll have another glucose with an H and an OH, and that H and OH will get removed. So water will be removed. This is called dehydration synthesis. And after that water is going to be removed, you'll end up with the glucoses then combined. So every time, if I lose another water, another glucose can be added. On and on and on and on and on. Every time I want to add another one, I can remove an H2O and put the glucoses together to ultimately build glycogen, which again, then glycogen can get broken down by this process called hydrolysis, so that each new glucose can get released, so that this process called cellular respiration can occur.